Hey guys, Easy Science here. If you're studying for an exam or just learning for fun, you've come to the right place. Today's topic are logarithms. A pretty hard mathematical concept, but we'll get through it. Okay, before we start, let's just see what a logarithm looks like. The most basic type would be just a logarithm of x. Yep. So that's just the simplest type. Now I'll give you some other types. So what does this mean? Well, logarithm is another way of thinking of exponents. So let's say there's something like 2 to the x, or even better, 1 second, 2 to the third is equal to 8. So a logarithm is basically like an kind of an inverse function of an exponential function. So basically, let's think about what do you think? Let's ask the question: what 2 raised to x is equal to 8? That's basically, you're asking what power does 2 have to be raised to equal 8? That's how we express a logarithm. So it would be b of x. Here, let me redo that. B to c. So b is equal to base. Like we know, of an exponent, the base would be 2. A is what we're trying to get. Result. And c is what power that we have to raise everything to. So let's go back here. If we use that formula, if we use it, then we could find out, we could rewrite it. So log of 2 the base of 8 is equal to the exponent 3. Here, so log of 2, that's the rewritten version of an exponent. That's the easy way of thinking about it. So you're basically trying to go back a step. You're trying to check the 2 out. Instead of having the exponent there, you're trying to find out which exponent to put into 2 to get 8. That's the easy way of thinking of it. So, okay, let's go to the next step. Check the other types of logarithms. Or even before that, let's take an example of a logarithm here. Okay, let's write logarithm of base 4 16 is equal to 2. Write that in exponential form. How do we start with this? First, as we know, if this is the base, we should write the base right here as an exponential base. So we didn't have the 2, we could have just used our profound thinking to find it out, or just done the square root of 16 or something like that. But when we have the result here, we plug that into the 4, so it'll be 4 squared be equal to 16. Easy, right? Yeah. In rewriting logarithms, you just take the base, and the thing next to the base is just the result. So you just need the equal thing on the other term to put into the exponent to get the number you want. So let's check the other types. Let's check log base 10 for now. Sorry for my writing. Base 10 of x. This is one of the most widely used ones. So what is this? Just a base 10. So we could try something. If this is equal to 100, we know it's going to be 10 to the squared is equal to 100. And it would be 2. Okay, we solved it. But what is this? Is this like something special about this? Yes. Because this can be written as log of x, just like that. It's just a normal logarithmic form without any base written there. So on calculators, usually this one pops up first. Okay, so if it doesn't show anything with a base on the calculator, the b in there, how do you solve things? Because you need the base. Well, I have a trick. So let's say it's log 4 base 4 of 16 is equal to 2. Right? Or we could just put the x there, put some mystery into it. So how do we do this on a calculator? Well, you could start off by you have to use the log base 10 thing in this case. The way I do it is log base 10 of 16 divided by log base 4 log base 10 of 4 be equal to 2. And it works. You could try it out for yourself. So basically what you're doing is finding what 10x would be equal to 16 all divided by which 10 of x would be equal to 4. So when you find these terms out, it'll give you which the bottom denominator has to be squared to get this term in the numerator. Easy as that. The last thing, or last special logarithm I'm going to talk about is the one that involves the Euler's number. What's the Euler's number? E? Well, it's a pretty nice concept which was used, founded out with life concepts. This number, E, is found everywhere, even in nature. So it's equal approximately to, excuse me, 2.71828. This number. I'll try to imagine it for you. Okay, I won't talk much about this magical number, but his name was Euler. Euler. And he lived a pretty long time ago. Here's a Wikipedia page. 1707. That's a pretty long time ago. So this guy invented or discovered one of the most magical numbers. I'll make a separate video on this, but let's just say you can have lots of properties with this number. Like for example, or here. So let's check the graph of e to the x. So again, same thing with the logarithms and exponentials. But let's say at point 1, it's going to be equal to e to the 1, which is e, this number. So e, and the slope or gradient, let's draw a tangent line, I'll talk about that in future videos, is also e to the x, and the area under the graph till negative infinity is also e to the x. So you could tell now that this number is magical. I'll talk more about it in future videos. But let's say use logarithm of base e to the x, or x. What would this be? This is what we call a natural logarithm. Natural logarithm of x, rewritten this way. Usually find this on calculators too. You could also use that division thing with these, but we'll get to that into future videos. Now, we're going to talk about logarithmic rules. One of the most important things solving equations. Okay, let's talk about the rules. First rule, simple. If you're doing a logarithm of any base of something multiplied by something, so let's say 2 multiplied by 4 and let's do natural log. This would be equal to natural log of 2 plus natural log of 4. Same with anything else. Here. Same thing with division. If you do natural log 4 divided by 2, it would be equal to natural log of 4 minus natural log of 2. Okay. Oh, not letting me make it big again. Let me tell you which ones are most important. I would say these three are very important. And let's see which other ones. They're all important, but why these ones? Because these ones will be in calculus a lot, and it would help you a lot. Same with this one. You could even rewrite something like, let's say something 2 to the x, and let's say y is equal to 2 to the x, and you want to solve this, but you don't want to go through all this process, so you just add a natural log or whatever, put it on the other side too, and ultimately becomes natural log of y is equal to x multiplied by natural log of 2. So it's very useful in ways. So what you're doing here is basically solving for m, multiplying by the exponent, because if you change the number inside the logarithm, so let's say it was 2 to the 4th, that would be the same thing. Say natural log of 2 to the 4th is the same thing as natural log of 16. Or, because you solved for the exponent. Or, same thing as 2 multiplied, natural log of 2 multiplied by 4. Because you just took it out, and then you're just solving for 2, and you're having 4 groups of those. So it's basically like doing 2 to the 4th, but with natural log multiplication. So before, it would basically be natural log of 2 multiplied by natural log of 2 4 times, right? Yeah. And the other rules, like natural log of anything to 1 is equal to 0, because it would be what exponent, let's say it's 2, it could be rewritten as 2 to the x is equal to 1. For every number exponential, that's 0, because 2 to the 0 is equal to 1. So let's check the other ones. The other ones are just as shown. Yeah. Okay. Let's do a little recap. Things to remember. Like what a logarithm is. What a log is. Log. Special logs. E, the Euler's number. Log rules, logarithm rules, and how to evaluate them. Valuation here. Yeah, I won't write that down. Okay, and thanks guys for watching my video. It might have not been as interesting as the other ones, but I tried to make it good and I put some work into it, so I hope you enjoy it. Thank you for watching again, and have a nice day. And if you, like I said again, if you enjoyed the video, please give me a thumbs up and comment for new videos. And if you want to see more videos like these, subscribe and I'll release many per week. See you guys.